Assalamualaikum, my name is Nur Ardina Syaira binti Abdul Rahim, and today we're going to present our project, which is a smart drip irrigation system.
Agriculture industry or agriculture farming is a way to producing a lot of food economically and profligate, such as meat, eggs, and vegetable. Traditional agriculture and the related sectors cannot fulfill the standards of modern agriculture, which needs extensive, high quality, and efficient production. Farmers have used the irrigation technique by means of manual operation, in which the farmer irrigate the land of frequent interval by switching the on-off water pump when necessary. Moreover, changing climate of plant and soil transformation are unpredictable.
Hello and Assalamualaikum. My name is Rozila binti Muhammad Sabri, DE 170045. Today I'm going to presenting objective and scope of this project. There are a few objectives that need to be achieved from this project. First, to understand the concept of smart agriculture using IoT, Internet of Things system. Second, to create a creative model design of smart agriculture using Node MCU, Node Microcontroller Unit Wi-Fi module. And third, to design smart agriculture system using MIT Apps Inventor application for Android and ThinkSpeak as IoT analytic platform for collecting the data. The scope of this project is determining the factor responsible for providing the necessary moisture for the plant development during unpredictable climate, and also help to prevent unnecessary water waste due to the traditional irrigation system. The project will be a benefit to gardener, farmers, and small agribusiness sector.
Hai, Assalamualaikum warahmatullahi wabarakatuh. I am Naim Diana binti Zulkifli with my matrix number CE170164. I am the group member number 1 from the section 2 group 6. For our IDP2 agriculture project, we choose to do the smart drip irrigation based on IoT. For my part, I will explain about the methodology. For the methodology part, firstly, the smart drip irrigation based on IoT is the automated irrigation system. We are building the system by using the ESP8266 Node MCU module. The soil moisture and DHT11 is used to detect the soil condition. This system not only irrigates water to plants based on the moisture level in the soil, but the data we get will also send through the MIT Apps Inventor to monitor, and the data then will be stored on ThinkSpeak to keep track the soil condition. The system is only need the water pump to drip the water to the soil depending to the soil moisture, temperature, and humidity. The motor will start to pump the water when the soil moisture is less than 50% and drip the water to soil. For the flowchart of smart drip irrigation based on IoT, flowchart is start by getting the data from sensor. Soil moisture sensor and DHT11 detect the soil conditions, humidity, and temperature. Then the data sent to the microcontroller Node MCU. The data is then transmitted via MIT Apps and it will transfer the data to cloud server and store the data via TeamSpeak. If soil moisture is below than 50%, then the water will pump to start the irrigation. If not, then the motor will not pump the water and continue to monitor the soil conditions until it reaches below than 50%. Next, for the block diagram of the smart drip irrigation, the microcontroller for the smart drip irrigation is using the Node MCU. The DHT11 and soil moisture sensor give analog output which can be read through ESP8266 Node MCU. The relay module is used to drive the 5V motor pump since the output voltage of Node MCU is only 3.3V. The motor will start to pump the water when the soil condition is below than 50%. The MIT apps invented is the apps that we designed to monitor the data we get from the microcontroller ESP8266 Node MCU. The data then will be transferred to TeamSpeak, where it is an open platform that will permit us to collect, analyze, and act on collected data. The data will be stored in the cloud server TeamSpeak. In the TeamSpeak, we create 3 field charts. That the field 1 chart is the soil humidity, the field 2 chart is showing the environment temperature, and the last one is the field 3 chart showing the environment humidity. For circuit diagram or the smart drip irrigation, the moisture sensor gives the analog output which can be read through Node MCU analog pin 0. Then the DHT11 and soil moisture sensor is connected to the microcontroller Node MCU so that the data can be read for the soil conditions. The water pump is connected to the relay since the Node MCU are not capable to give the output voltage greater than 3.3V from its GPIO. The relay module drives the 5V motor pump to pump the water for the soil. The soil moisture sensor and DHT11 is powered from external 5V power supply.
Hi, I'm Siti Sarara Imam binti Muhammad Yasir with matrix number AE170130, and I will be presenting the results and analysis of our project.
As for the results and analysis of this project, there are 2 conditions of the plant that we set in order to exhibit the performance of our system. That is Plant A and Plant B. Plant A is watered 2 times a day manually, while Plant B utilized our system fully. After a few weeks of observing the plant, we managed to obtain the results. As for the Plant A, we observed that the plant leaves and stems are in yellowish color. While Plant B, the plant leaves and stems are green and appeared to be healthier than Plant A. From our observation results, we could see clearly the difference of the quality of both plants from the color of their leaves and stems. And the most common reason of a plant to turn yellow is because of moisture stress that resulted from underwatering. The condition of Plant A mimics our usual routine whenever we grow a plant. Most people believe that watering a plant twice a day would be sufficient, but the plant clearly needs more than that, considering our country's weather. As for Plant B, we monitor the plant from the application that reads the soil condition every 1 hour. If it detects the soil's humidity to be under 50%, it will release the water for 6 seconds to increase the humidity of the soil, hence increasing the quality of the plant. Therefore, from the results, we could see the effectiveness of our system that already being exhibited by Plant B. That's all from me.
In order to complete the project, there are some challenges had been faced due to MCO. First, miscommunication among group members. This is because some of the group members are not able to join the meeting through Google Meet to discuss about the project, so they might miss some of the infos. Although everyone uses WhatsApp as their communication platform, they might lose the information due to internet coverage or maybe their limited time. Second, difficult to get component for hardware part. Since all group members stay at different places, we had decided to choose one person to in charge the hardware part. Since the person place does not have the supplier for the component, she must buy it online and it will take time to receive. So it might drag the time. Third, face problem to troubleshoot. Even though before doing hardware part, other member must do the software part, which is coding, circuit and so on. For software part, they have built successfully, but when come to hardware part, sometimes they have some error. So it take time to troubleshoot. Since everyone is far and SV also far, so it is quite difficult to troubleshoot and it will take time to settle down.
Hi, my name is Azrina binti Zaini. Matric number CE170123. Okay, I will explain for demonstration part.
Okay, I will explain for the prototype of this project. Okay, I will explain for the circuit. In the middle is the node MCU. This is the soil sensor, DHT11 sensor, relay module, water pump, pump in, pump out. Okay, I will demo the project. Okay, for the demonstration part, I will use two material, which is cup A, cup B, which is cup A is for soil, and cup B is for water. Okay, when the sensor is read the condition of the material, the node MCU will send to the MIT App Inventor, which in the user phone, which is this is the apps in the user phone, which is we have soil humidity, environment temperature, and the environment humidity. At the same time, we have the graph, which is all reading that had been recorded before this. Okay, first I will put the sensor in the soil, which is the water will be coming up from the water pump for 6 seconds, and the reading is 50. This is the humidity soil. Next, we put the soil in the water, and the water is not coming up since the humidity soil is 70%. So the water will not coming up. So that's all for our demonstration.